All right, how's it going? It's your old pal, Mr. Cook. We're going to work on the extra practice for Unit 2, Part 2. Make sure that you have your graphing calculator handy because we're going to use this thing an awful lot. Okay, here we go. So write two polynomial functions having a vertical reflection of each other with the given roots. Okay, so a vertical reflection, what the heck? So that means that it's just reflected over the line, the x-axis. You know what? Let's not do that because that's kind of stupid. Let's just come up with two different polynomial functions that have all these zeros right here, because that's really what we're kind of interested in right now. So if we have these zeros, we write up the two factors. The three factors that go along with them. So a factor, if you need to find it, is just going to be x minus whatever zero value that you get. So in this case, one of our zeros is 0, so one factor is going to be x minus 0, and then another one's going to be x minus 3, and another one's going to be x minus negative 4. So, to make this look a little bit nicer, x minus 0 is just going to be x, so I'm just going to change that to an x. There we go. And then x minus 3 is good, and then when I subtract a negative, it's the same as adding, so I'm going to change that to x plus 4. And there's one polynomial. I can make another polynomial really, really easily by just adding in a different coefficient. So I just put the same thing here, x minus 3, x plus 4, sorry. And then I could just put in like a 2 or something. The reason that they wanted to do the vertical reflection is just by putting a negative in front. I don't know. I guess we can do that, but it's more interesting to put something like a 2 or a 3 to make it a little bit more eccentric. But yeah, the negative is all it's really asking for. All right, so continuing on, if we're using 2, that's going to be x minus 2. If we have negative 2, that's x plus 2. And then if we have a fraction, if we have x minus 1/2, remember what we do with that. When we have a fraction, we move the denominator out front, so this becomes 2x minus 1. And then for the other one, if I have x plus 1/2, then we move the denominator out front and we get 2x plus 1. All right, so those are all the factors there. And now with the other one, if we just put a simple coefficient in front of it, then we get a whole nother polynomial if we want. If we want to use the rule, the question that is asking, then we just put a negative in front instead. It just really doesn't make that much of a difference either way. We're just making two different polynomials from it. Determine the end behavior of the graph of the polynomial function. So end behavior works like this. We need to look for the degree and then also the sign on the polynomial. So if the degree is even or odd, something happens. Then if the sign on the lead coefficient is positive or negative, something happens. So if it's even and positive, then the end behavior is left up and then the right is up also. If it's even with a negative lead coefficient, then on the left side of the graph it's pointing down. On the right side of the graph it's pointing down. If we have an odd degree and a positive sign, then on the left-hand side it's pointing downwards, on the right-hand side it's pointing up. And then if we have an odd degree and a negative lead coefficient, it starts on the left-hand side by pointing up, and on the right-hand side it's pointing downwards. So let's take a look. So we have a degree of 5, so that's an odd number, and then the lead coefficient is negative, so odd and negative means that it's pointing up on the left and then down on the right. All right, so find all the real zeros of this function right here. Well, I know that I can factor out an x, so I factor out the x, and I get x to the 4th power minus 5x squared, and then plus 4. All right, so that's one way to factor it out right now. I'm going to go to my graphing calculator to look for a couple other zeros. So I just go to y equals, and then x to the 5th power, x to the 5th, and then minus 5x to the 3rd, minus 5x to the 3rd power, and then plus 4x, so plus 4x, and then I graph it out. And I've got zeros. Let's see where they are. Looks like I've got one at -2, -1, 0, 1, and 2. So, I can just use synthetic division from here on out and find, prove the rest of the zeros. But those are all my zeros right there. You can even count them up. 1 at -2, 1 at -1, 0, 1, and 2. So that's a total of 5, and I'm supposed to have 5 because the degree is 5. So all my zeros are those, -2, -1, 0, 1, and 2. To show my work, I'm just going to use synthetic division. I guess, I'll just, instead of factoring, let's just go ahead and use the synthetic division for that. So all right, we start with x to the 5th. Let me get a different piece of paper so then I can get all my work on one sheet. Where do I have a little piece of paper here? Here we go. So there's going to be a little bit of syntactic division on this, so I want to make sure that I have enough room. Okay, so x to the fifth, so we have a 1 for x to the fifth. There's no x to the fourth, so we put a placeholder there. X to the third is -5. X to the second, there's nothing there, so we put a placeholder. 4x, and then there's no constant value, so we're going to put a 0 there. All right, and then our first number that we're going to use for synthetic division is -2 for our 0. So we go ahead and you know, we can drop that one down if we want. So 1 times -2 is -2. 0 plus -2 is -2. And then -2 times -2 is 4. 4 minus 5 is -1. -2 times -1 is 2. 2 times -2 is -4. 4 minus 4 is 0. And then 0 gives me that. Okay? And that tells us that it's a 0 because our remainder is 0. Another 0 we have is at -1. So we use -1 with synthetic division for the rest of these coefficients. So -1. And then just work through it. So let's see here. 1 times -1 is -1. -1 and -2 makes -3. -1 times -3 is a +3. 3 minus 1 is 2. 2 times -1 is -2. 2 minus 2 is 0. 0 times -1 is 0. And 0 plus 0 gives us 0. So that means that we have another 0 at -1. And we continue going with this. So plug in 0 now for synthetic division for our next 0. So we get 1 times 0 is 0. 0 minus 3 is -3. -3 times 0 is 0. 2 plus 0 is 2. 2 times 0 is 0. And we get 0 for that as well. All right, so that's another 0. And then we're going to use our next 0, which is 1 with synthetic division. So if we plug in 1, 1 times 1 is 1. 1 minus 3 is -2. -2 times 1 is -2. And we get another 0 for 1. Then our last one should be 2. Let's prove that that one works as well for synthetic division. So what we're going to do is take this linear equation, 1x minus 2, set it equal to 0 and solve. So if we just simply add 2 to both sides, we get x equals 2. And that's the last of our zeros. So 2, 1, 0, -1, -2 are all of the real zeros that we have. And here's the work to prove it. Okay. Find the polynomial function with 0, 3, -2/3 as its zeros. So with 0, that's easy. We're just making factors and multiplying them together, basically. So we have x minus 0, x minus 3, and then x minus a -2/3. So x minus 0 is just x. X minus 3 is x minus 3. And then when we have a fraction, we move the decimal to the, when we have a fraction, we move the denominator to the front, so that's 3x. And then minus a negative is plus, so plus 2. And if we wanted to put this in expanded form, it's pretty easy. We just distribute these or FOIL these two binomials together and then distribute the x in. So we have x times 3x, which is 3x squared, and then x times 2, which is 2x, -3 times 3x, which is -9x, and then -3 times 2, which is -6. Then we have the x out front still. Combining like terms, I get 3x squared minus 7x minus 6. And then distributing the x in there gives me my polynomial, which is 3x to the third minus 7x squared minus 6x. And we're all done with that one. All right, next we want to graph this by hand. So sketching polynomials is pretty easy. One thing that you can do is start factoring. So I notice that I have an x right here and an x right here, so I factor that out and I get x times parentheses x squared minus 4. And x squared minus 4 is a difference of squares, so I can factor that real easily. So that's x plus 2, x minus 2. And just like that, I have all my zeros. This gives me a 0 of 0. This gives me a 0 of -2. This gives me a 0 of 2. And all of them have the same multiplicity, and that's 1. So on my graph over here, I go to 2 and -2. Those are my zeros there. And then I have another 0 at 0, so that's through the origin. Now, this is an odd degree, and then also a positive lead coefficient. So if I go back to my end behavior, odd degree positive lead coefficient means that the graph starts by pointing downwards, and then it's going to end by pointing upwards. So we're just going to fill in the rest of it. Since the multiplicity is odd for each of these, for each of these zeros, it's going to cross through the x-axis, so it passes directly through it. Then since it's continuous, it's going to make its way back down over here when it's going to cross through the x-axis. Then it's continuous, so it's going to make its way over to this x-intercept and go through again, so cross through all of them. And that's kind of like a rough draft of how our graph would look. We can flesh it out by getting a couple extra points if we want, but there's no real point to it right now. All right, next up, number 7. So we need to divide these. This doesn't say to use synthetic division or long division, but I'm going to practice using my long division skills on some of these. So number 7, I've got 3x to the 4th power minus 7x squared plus 2x minus 10, and I need to divide that by x minus 3. So what I'm going to do is make this x look like 3x to the 4th. So to do that, I multiply it by 3x to the 3rd. So 3x to the 3rd times x gives me 3x to the 4th. 3x to the 3rd times negative 3 is a negative 9x to the 3rd power. Oh wait, something went wrong here. And yeah, it looks like I've forgotten like my placeholder value over here. So I got to remember to put placeholders in to make sure that everything lines up. So since I have x to the 4th but no x to the 3rd, I need to account for that by putting a plus 0x to the 3rd in there. And then the rest of it, so minus 7x squared plus 2x, and then minus 10. Okay. So now this is making more sense because now I can just line this up, subtract these values away, and then get a remainder afterwards. So 3x to the 4th minus 3x to the 4th, they cancel out. 0x to the 3rd minus a negative 9x to the 3rd gives me a plus 9x to the 3rd. And I drop down the next term, negative 7x squared. So to make x look like 9x to the 3rd power, I need to multiply it by 9x squared. So 9x squared times x gives me 9x to the 3rd. 9x squared times negative 3 is going to give me a negative 27x squared. So I subtract all this stuff away, so I get the 9x to the 3rds cancel out. Negative 7 plus 27x squared gives me a positive 20x squared. And then I drop down the next term, which is 2x, so plus 2x. So to make x look like 20x, I need to multiply it by, to make x look like 20x squared, I need to multiply it by 20x. So 20x times x is 20x squared. 20x times negative 3 is a negative 60x. So then I subtract these away, and I get, let's see here, so the 20x squareds cancel out. 2x plus 60x is 62x. Sorry about that, did a little mental error right there, so 62x. And then I drop down the negative 10. And now to make x look like 62x, I need to multiply it by a positive 62. So 62 times x is 62x. 62 times negative 3 is negative, 186. So then if I subtract those values away, negative 10 plus 186 gives me a positive 176. So that ends up being my remainder. So overall, my polynomial answer here is going to be 3x to the 3rd plus 9x squared plus 20x plus 62 plus that remainder of 176 over my divisor, which is x minus 3. And that's the long division part of it. Okay, so let's do another long division problem, number 8. So I have x to the 3rd minus 11, so x to the 3rd minus 11 divided by x squared plus 2x minus 1. All right, so I'm not going to get fooled again. I have that x to the 3rd, but I don't have an x squared or an x, so I'm going to put placeholders for those. So plus 0x squared, plus 0x, and then finally minus 11. All right, so let's divide this out. So again, I want this lead term to look like this x to the 3rd, so the only way to do that is to multiply x squared by x to get it to look like x to the 3rd. And then if I multiply those through, x times 2x is 2x squared. X times negative 1 is a negative 1x. All right, so then I subtract that whole thing away. The x to the 3rds cancel out, and then I get 0 minus 2x squared, so that means it's going to be negative 2x squared. 0 minus a negative 1x, that's the same as adding 1x onto there. And then I'm going to drop down that negative 11 as well. Okay, so now I need to make x squared look like negative 2x squared, so I multiply it by negative 2. Negative 2 times x squared is negative 2x squared. Negative 2 times positive 2x is going to be a negative 4x. Negative 2 times negative 1 is a positive 2. So then I subtract those away. The 2x squareds cancel out. 1 minus a negative 4 is the same as saying 1 plus 4, so that's going to give me a total of 5x. Negative 11 minus 2 is going to be a negative 13. And since I can't turn that x squared into a 5x without dividing, I'm done. This is my remainder, believe it or not. So that means that my answer overall is going to be x minus 2 for the quotient, and the remainder of 5x minus 13 is going to be plus 5x minus 13 over my divisor, which is x squared plus 2x minus 1. And that's my finished answer right there through using polynomial long division. All right, then the last one that I have for polynomial long division is going to be this one. So I've got a fifth, a fourth, but I don't have a third, a second, but I do have a first power and a constant. So I write all those under there with my placeholders. So 3x to the fifth plus 13x to the fourth power plus 0x to the third plus 0x squared plus 12x minus 1. And I'm dividing all of that by x plus 5. Boy, that's a lot of work, isn't it? Well, it's just practice, remember, and this is leading into the test. And, I'm sure that I've said this in class. I'm sure your other teachers have said it too, if you've heard it from other honors algebra 2 teachers, that, the extra practice and the group work, they're much harder than the actual test. So if you're feeling down on this, but you feel like you understand how to do division, chances are you're still going to do fine on it. Just make sure that you keep practicing and maybe look over some of the old homework problems that you've worked on. Anyways, so to make x look like 3x to the fifth power, I have to multiply it by 3x to the fourth power. So if I do that, 3x to the fourth times x is 3x to the fifth. 3x to the fourth times 5 is 15x to the fourth. So if I subtract these away, the 3x to the fifths cancel out, and 13 minus 15 is negative 2, so I have negative 2x to the fourth. And then I drop down my plus 0x to the third. So to make x look like negative 2x to the fourth, I need to multiply it by negative 2x to the third power. So negative 2x to the third times x is negative 2x to the fourth. Negative 2x to the third times 5 is going to be a negative 10x to the third power. So if I subtract these away, 0 minus a negative 10 gives me a positive 10x to the third. I drop down my x to the second power and start it again. So to make x look like 10x to the third, I need to multiply it by a positive 10x squared. So 10x squared times x is 10x to the third. 10x squared times 5 is 50x squared. So if I subtract these away, these cancel out and I get negative 50x squared. Then I drop down my 12x, so plus 12x at the end there. To make x look like negative 50x squared, I need to multiply it by a negative 50x. So negative 50x. Negative 50x times x is negative 50x squared. Negative 50x times 5 is going to be negative 250x. Oh boy. So these are going to be some pretty big numbers here. The x squareds cancel out, and then 12 plus 250 is 262x. And then I drop down the minus 1 at the very end. And to make x look like 262x, I need to multiply it by a positive 262. Oh man, I got to multiply that by 5. Oh geez. So 262 times x is 262x. 262 times 5, oh, I'll just use my calculator for that, whatever. I was going to try and do something cool like multiply it out in my head, but it's a little late in the day, so I don't trust my multiplication skills. So 1,310, so I'm adding that on there. All right, so the 262x's cancel out, and the negative 1 minus 1,310 is going to be a negative 1,311. So that's our remainder. So we end up with 3x to the fourth minus 2x to the third plus 10x squared minus 50x plus 262 plus that remainder, negative 1,311 over the divisor, which was x plus 5. Yikes, that's a lot of work. Luckily for the next one, we just have to do synthetic division. So synthetic division is pretty easy. It says to use synthetic division to find f of negative 6. So this is using the remainder theorem. So whenever you need to find what that's equal to, just put that number in the corner for synthetic division, and then use the algorithm to find the remainder. Whatever the remainder is, that's going to be your answer. All right, so we have the lead coefficient of 7. So 7x to the third, 40x squared, negative 12x, and then 15. So we drop down the 7. 7 times negative 6 is negative 42. 40 minus 42 is negative 2. Negative 2 times negative 6 is positive 12. 12 minus 12 is 0. 0 times negative 6 is 0. And then when we add those two together, we get 15. So that means that 15 is our answer by the remainder theorem. All right, last one on the first page, number 11. given the function, list all the zeros, give the multiplicity of each to 0, and then also state if the graph crosses or touches. This is such an easy problem because it's already factored out. So all we need to do is take each factor, like x, x minus 2, and x plus 3, and then we set each of them equal to 0 to find the zeros. So this one already is a 0. 0 is one of our zeros at x equals 0. X minus 2 equals 0 implies that x is also equal to 2, so 2 is another 0. And then x plus 3 equals 0. If I subtract 3 from both sides, means that I get my last 0, which is negative 3. All right, so those are all my zeros. Let's make a little table. Zeros there. Now let's check the multiplicity. So the multiplicity for each of them is just the power on each of the factors. So where my x was equal to 0, that has a multiplicity of 2 because the power on it is 2. For x minus 2, it's raised to the third power, so that's its multiplicity, 3. And then for x plus 3, it's raised to the fourth power, so it has a multiplicity of 4. Now, whenever you have an even multiplicity, that means that it's going to touch the axis, or in other words, it's going to be tangent to it. And then if you have an odd multiplicity, that means it's going to cross through the axis, or just go right through it. So for each of these, with the multiplicity of 2, that means that 0 touches the axis. With the multiplicity of 3, 2 will cross the axis, and with the multiplicity of 4, negative 3, we will touch the axis as well, because it's another even number, odd number. That means touch, and cross, respectively. All right, so that's the first page of the extra practice. If you need some additional help on it, just make sure to ask for help through, from your teacher. Send them an email, send them a text, whatever you can to get that help, or just show up in the morning and get some help in, whatever room that you're in. All right, so. That's it. Now let's move on to the second page.